All right, solving log equations. Okay, so it says by first isolating the logarithm if necessary. So in this case, all we have to do is try to rewrite this as an exponential equation. 6 to the power of 2, so remember, this becomes the base of the exponential form, and this becomes the power, and then the x becomes the output. So this is just 36. And we can sort of see that, like, if we plug it back in, plug in 36 for x, we can see this is true because 6 squared is 36. Okay, next one. We have to go right to exponential form. So this 2 becomes the base, this becomes the power, and this becomes the output. Just have to memorize how that works. So 2 cubed is 8. Then we can just subtract 5 on both sides. So x is 3. This one, we've got a little bit more work to do. If you've got numbers outside multiplying by the log and subtracting, we got to take care of that first before we convert to exponential form. So add 2 to both sides first, because we don't want to multiply or divide by 3, because we're going to have to divide this by 3. We really don't want to do that. So instead, we want to add 2 to both sides first. Keep this as 3 log 5 equals 6. Now take care. If we divide this by 3, it just affects that. Log base 5, 4x plus 1 equals 2. Now we convert to exponential form. This is the base, power, and output. So that's 25. Let's just get rid of that. Subtract 1 on both sides. Divide by 4. And we have x equals 6. As long as our number is a whole number positive, we should probably have nothing to worry about. But remember, the input, so the total value of this parentheses can't be negative. So we might run into that eventually. Okay, these, we have to use the properties of logs first. So combining logs or condensing into one. So notice we have the same base, so we can write this as 1 log. The operation in the middle is subtraction, so subtraction goes with division. We take the first number, first expression, divide by second expression, copy down the 3. Convert to exponential form. This is the base, the power, and then this big ugly expression is the output. And now convert this to 8. And this is something a little bit new. How do we deal with this? Well, this is 8 over 1. Whoa, what's going on? Wow, we don't need to zoom in, but that's kind of cool. 8 over 1. And maybe, you're familiar with cross multiplying, or, really just to get rid of a denominator, we know we have to multiply by that, because that's going to cancel that out. So that's going to move this over to the other side. So now we have 8 plus 8x. Let's write this here. 8 plus 8x, because we're distributing, equals 3x plus 23. And now it's a linear equation. You can subtract 3x on both sides. So I get 5x. And then subtract 8 onto the other side. 15. Divide by 5, and I get 3. Okay, and then I could plug that in. It's kind of a mess, but check it, see if it works out. It's a positive number. It doesn't seem suspicious, so should be right. Next one, we've got, careful, this is a parentheses, secret parentheses here. Combine this. So when the operation in between logs is addition, then we multiply. So we have to do x times x minus 3, all inside there, and that equals 1. So now this is going to become x squared minus 3x if we distribute. And now this is always a problem for students. To rewrite this in exponential form, like, we can't just divide by log. That's not a thing. Log has to have an input. So this is log base 10 if there's no number there. So we have to take that base, raise it to the other side, and out pops a quadratic equation. 10 to the first power is just 10. So quadratic equations, we want 0 on one side. So subtract 10 and try to factor or use quadratic formula, but most of the ones I give you, I want you to factor. So x, two numbers that multiply to get -10 and add to get -3 would be 5 and 2. And it's got to be -5 and plus 2 because it's got to add a -3. So the bigger number has to be negative. And that means x could be 5 or -2. But negative numbers are a problem with logs. We can't plug in -2 right here. It doesn't exist. So only the 5 is going to work when we try this. Log of 5 plus log of 2 equals 1. Because if I plug that in there, this is, kind of hard to show that it's true. Check it. You have to really check this with a calculator. Okay, and then on to some harder ones. So we got logs on all three sides of the equations. Actually, this might be a little bit easier because this part, we recognize same base, so we condense, combine into 1. Addition means multiplication, so x times 9, 9x. Then just rewrite the other side, and there's no need to convert to exponential form because I can see right here, if these bases are the same, then these inputs must be the same. So 9x must be 45, so x must be 5. Okay, same kind of thing going on here, only with subtraction. So condense the first two logs. Subtraction means division, so 2x plus 1 over 3. Take this 2x plus 1, this 3, write it like this. Okay, then if these logs have the same base, which is 10, and they're equal, then these parts must be equal. Sorry, that should be to the 5. 2x plus 1 over 3 must be equal to 5. Multiply both sides by 3. 2x plus 1 equals 15. 2x equals 14. Subtract 1. And then x must be 7. 7 is not that suspicious of a number. It's not negative. It should work when we plug it back in. Okay, hope that helps you. Thanks for watching.